How's it, grade 12? Okay, so we're going on to video 2 now. It's going to be example 2 and 3 for similar triangles. So just to read out example 2, it's saying that PRQ is equal to 90. So PRQ is 90. So I'm just going to mark that in there. It's also given that TS is perpendicular to PS. So this is also 90. Okay. It's asking us to prove that A, triangle PRQ similar to triangle PST. Question B, that RQ to PQ is equal to ST to PT. And then question C, PR times PT is equal to PQ times PS. Okay, so let's have a look at A. We need to prove that triangle PRQ is similar to PST. So the smaller one to the bigger one. Okay, so in triangle, I'm just going to write it how they've given it to us. PRQ and triangle PST. So we need three things to prove similarity. So the first thing I'm going to see here is that we've got this PRQ and PST. This angle P is common with both the triangles. So I can say here angle P is equal to angle P, and my reason is common. Okay, the next thing I'm going to have a look at, this PRQ, the smaller one, that's 90, that angle R, and this angle S is 90. So we have that angle R is equal to angle S, and they're both equal to 90. And my reason for that, given. Okay, so the next thing I'm going to have a look at is this Q and T. Okay, Q and T. Now there's no obvious reason just looking at it why that is equal to that. So because I've got two sets of angles that are equal already, I can use the quick way, which is this is Q2, so we can say that angle Q2, and remember, keep it in the correct triangle. So Q2 would be equal to angle T. And my reason for that is interior angles of a triangle. Okay. So now I've proved similarity. So therefore, triangle, and I read it down like this, PRQ, similar to triangle PST. And my reason for that, angle, angle, angle. Okay, so we've proved that first one. Let's have a look at question B. Okay. They're asking us for some kind of proportions going on here. So before I start on this one, I just want to get my proportions coming out here. So we know that PR over PS, so PR over PS is equal to RQ over ST, which is equal to PQ over PT. And my reason for this, similar triangles. Okay, so now we're ready for question B. So I am looking for an RQ. RQ, there's my RQ. So I need to choose this one. So we have RQ over ST equals, and now I'm looking for an ST, well, and a PQ. So there's our PQ. And you see our ST is going to come from this one here. PQ will come from that one. And have a look there, PT, PT. So PQ over PT. So I used this one with this one. And my reason for this is because we have corresponding sides, similar triangles. Okay, so what I'm going to do now is I'm just going to multiply that up. Oh, what I can do here is I can just swap these around. I can take that one up there and that one down there. So I'm just multiplying up by ST, dividing by PQ. So we get that RQ over PQ is equal to ST over PT. Now you're probably saying, well, that's not the same as this. Yes, it is. Okay, because, and I'm just going to, this is not part of the reason. I'm just going to rewrite this. That is the same as saying RQ to PQ. You remember that's what the division line means, is equal to ST to PT. And that's exactly what they wanted. Okay, so looking at question C, they want us to prove that PR times PT is equal to PQ times PS. So if I have a look back here, I need a PR. So there's our PR, so I'm going to use this one. And we need a PQ, which is this one here. So we've got, just using this, so we got PR over PS is equal to, and we need this PQ1, PQ over PT. And my reason for that is corresponding sides, similar triangles. Okay, so now all I'm going to do is I'm going to multiply up by that PT, multiply up by the PS. So we get PR times PT is equal to PQ times PS. And we've proved it. Okay, going on to example 3. So example 3 is telling us that given angle A1 is equal to angle C. All right, prove that PA squared equals PB times PC. So let's have a look here. So we've got this PA is over there, okay, and then we've got another PA. Then we have a PB, which is this one here, and we have a PC. So that's going to help us decide which triangles we're going to be working in. So as you can see, the PA belongs to both of them. Then we have a PB. So we have PA, PB. So that must be this smaller triangle here, this PAB triangle. So that's the first thing I'm going to do is I'm going to say in triangle PAB. And the reason why I'm doing this, grade 12s, is because I want to prove similarity. Then I can get my ratios coming out. So again, now let's do this again. So we've got a PA side and we've got a PC side. So that must be this triangle PAC. So, and triangle PAC. The order over here doesn't make a difference. The order will come from where you prove similarity, and then you write your conclusion, okay? So 1, 2, and 3. So the first thing I'm going to say is we've got this PAB and then PAC. This angle P is common with both of them. So angle P equals angle P, and that is common. The next thing that they've told us is that this angle A1 is equal to angle C. Okay, so angle A1 is in the PAB triangle, which is this one here. So we get A1 is equal to, and angle C is in the bigger one. And that was given to us. Now I can figure out what my third angle should be. So I have a PA, I need a B, will be equal to, I have a PC, so I need an A over here. And that reason is interior angles of triangle. Okay, so the thing to notice here is you can see PAB, PAB, that was the same. Here we have PAC, but we're getting out PCA. So like I said, this order in the beginning doesn't make any difference. It's when you prove similarity. Okay, so therefore, triangle PAB similar to triangle PCA. I'm going to stress that again, grade 12s. This order is very important because you're going to get your proportions coming out just now, okay? And our reason for this is angle, 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 okay? So I'm just going to get my proportions coming out. So we have PA over PC equals AB over CA, which is equal to PB over PA. Okay, so now we can decide which ones to use. So I want a PA, so I'm going to use this one over here. And if you have a look, we've got the PC. So that's cool. So we're going to use this one, PA over PC. But now we need to get a PB and another PA, because that's squared. So here's a PB and there's a PA. So equals PB over PA. Reason, similar triangles. Okay, so if I multiply up by the PA and multiply up by the PC, PA times PA will give me PA squared equals PB multiplied by PC. And that is what they wanted us to prove. Okay, so grade 12s, I would like you to do exercise 7 for me, please. Thank you.